Hello everyone, in the previous video we built a function spiral matrix that, given an initial value, arranges the numbers in a spiral order along a square matrix. In this video we do the opposite. We give a final value and the numbers will be arranged in a spiral order but backwards. So the plan of the video is the same as the last one. So first of all I show you what the function does, then we write the function, we test the function, and finally we break down the function. So let's start by importing NumPy. Now I'll show you what the function does. An example with a 3x3 matrix with final value 9. And as you can see, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's see another example with a 4x4. Let's go 5x5, 6x6, 7x7. Now, let me show you a main difference with the previous function. Here we give a final value, but as you can see in this 3x3 the final value is located here, but when we go to a 4x4 the final value is located here, and if we go to a 5x5 the final value is located here. Basically the location of the final value changes and it depends on the size of the matrix, number of rows, number of columns, and if the number of rows and number of columns are even or odd. So, for example, here, this is odd, and I would refer to this as odd matrix. As you can see, the final value is on the row in the middle, column in the middle. And this is the same also for a 5x5. Row in the middle, column in the middle. 7x7, here we choose 51 as final value, 0 in the middle, column in the middle. On the other hand, when the matrix has even number of rows and columns, and I will refer to this as even matrix, we see that the final value is here, is located at row index 2, column index 1. When we go to a 6x6, it's row index 3, column index 2. So as we can see, there is a difference of 1 between the row index and the column index. Another main point that we have to take care is the rotation. Here, when the matrix is odd, rotation goes from right to left, top down, left right, bottom up. It starts again. But when it's even, goes from left to right, bottom up, right to left, top down, and starts again. Okay. Last point is that in the spiral matrix, when we give the initial value is here. And as you can see, regardless of the number of rows and columns, that is, if the matrix is even or odd, we always end up from right to left. As you can see here, this is 4x4. We end up from right to left, but this is the same here. Rotation is different. This is 5x5, but we also end up from right to left. And this is where we will place the condition to check if we have to stop the loop. Okay, so let's go now to write the function. So again, we start with a docstring. Here we check that the matrix is square. And now here is the difference with the previous function, because we are checking if the number row column is even or odd by check the remainder. So if the remainder is 0, we have an even matrix. And as we said, there is a difference of 1 between the row index and column index. And this is what we are writing here. And this will become the location of this FV final value here. And there, the rest is very similar. We set the initial value we control the loop sequence. We set the condition to fulfill to stop the loop, and then the while loop starts. This is from left to right, from down to up, from right to left, and yeah, we check some, so we break the loop if the condition is fulfilled, from up to down, and then we update the initial values. If n is different from 0, as you see, this is the new location of the final value. We set the initial values to control the loop sequence. Again, we set the condition to fulfill to stop the loop. Here, we write the loop. But this time we go from right to left, from up to down, from left to right, from up to down, and we update the initial values. And then we return the object. So let's run this function here. Now let's test it. This is 8 by 8. We set 64 in the final value, and we end up here 1 initial value. Let's try this one. And as you can see, now we get an error. The matrix must be square because we gave a 7 by 8 matrix. Let's go again, 8 by 8. We start now from minus 1 is the initial value, the final value. And we end up at minus 64. Let's go 9 by 9. Final value 0. We end up at minus 80. Ten by 10. Final value 100. We end up at 1. Last example here. Final value is minus 1. We end up at minus 100. Now let's break down the function. We just break down the even matrix. Let's do an example 6 by 6. So we set final value equal 8. Here we are checking if the matrix is odd or even. And this is even. So reminder, this is 0. Let's set the final value. So as you can see now, we populated with the final value 8 in this location. These are all the conditions here to control. We set these initial values. Here, so this is the same case as last one in the last function. So we have we set a minimum value here, 1 plus final value minus number of rows square. What does that mean? Is the final value, for example, this is a 6 by 6, right? So this means that this is 36. If we set 36 as final value, this goes to 0, and the minimum value will be 1. So the sequence will go from 36 basically to 1. Now this is 8. So 8 minus 36 plus 1. Okay, and this is minus 27. Here we set the SV, SM. These are the condition to control for the while loop. And here this is as the sum from the final value to S min going backwards. And the sum here, SV, is 414. We have SM that now is just 8 because the matrix just stores the final value. So we have to go from 8 to 414 when the loop will stop. Okay. Let me show you, for example, here. See, this is the range. We are going from 8 backwards minus 27. But here we are working with absolute value. And again, the reason is the same as the last one, because if we don't work with absolute value, this number will cancel. Okay. And here it's 414. And let's print the matrix. Again, we have only this final value 8. So let's start the loop. Let's print always the sequence. You see, we just made one step. This is here for we move to from column row index 2 to column row index 3. This one. Okay, and now we have 7. Now we have to move again just one step. Here we have to move from row index 3 to row index 2. This is what this number 2 mean. So let's go. And as you can see now 876. Okay, here, what does this means? This line code is new. Basically here, when we go from right to left, I know that at a given point, this list will contain a -1. And basically I want to remove this -1. Okay. I think there are more elegant way to do this, but this works fine for us. So we have to move 2 steps to 1. As you can see, from 6 went 5, 4. So column index 2, column index 1. Here, because we are going from right to left, we check the sum. And as you can see, we are still very far from our final goal. From 4, 3, 2. Now, we have to update the initial values. And the loop continues. So we are here. Remember, the beginning was just one step. Now, if we run this sequence here, it's 2, 3, 4. So we have to do 3 steps. So we're here, 1, 2, 3 steps. Okay. You can see from here, we go to -4 here. And again, we have to complete the second round, but still we have to fill the matrix. So we have to update again the initial values. So here. As you see, we have completed the last row. We have completed here the last column, and now we have to go just from right to left. And we have completed. Now we check the sum, and you see this sum are equal. So this is the condition to break down the loop, to break the loop. So I hope this video is useful. I leave you the link for the same function written in R if you're interested. And if you enjoyed this video, see you in the next one.